In this section, we're going to be evaluating algebraic expressions. So what is an algebraic expression? Let's say we have the expression 2x minus 6. And this describes some real-world situation. An algebraic expression consists of variables and numbers and some sort of arithmetic operation, in this case a subtraction sign. Now this expression doesn't have any value because we don't know what the value of x is. So all we can do is simplify this. But let's say we're going to let x equal 8. We're told that the value of x is going to be 8. What we can do here is we can substitute 8 into our expression where everywhere there's an x. There's only one here, but everywhere there's an x in our expression, we would substitute 8. So what this would give us is 2 times 8. 2 times 8 instead of 2 times x. We're substituting 8 in for x, and minus 6. Now notice what we did here. We're defining our variable x as 8, so everywhere that we're substituting in 8 for x, we're going to put 8 in parentheses. Now this helps clarify what we're actually doing. It helps us, remember where we're substituting in for a variable, so we don't get confused here. Our order of operations says we multiply before we subtract, so 2 times 8 is 16. Carry our minus 6, and then 16 minus 6 is 10. So this means for the expression 2x minus 6, when we let x be 8, this expression has a value of 10. Okay? Very important, so we want to do a few more of these. Let's say we have minus 8x plus 4. And here, we want to let x equal minus 2. Okay, this is given. We don't have to figure this out. This is given. What we want to do is figure out the value of the expression when x is a minus 2. So how do we do that? Well, we plug in minus 2 into our expression everywhere that we see x. We only have one x, so this is fairly simple. We have a minus 8 times a minus 2 and plus 4. Now also when we use our parentheses when we're substituting, it actually clarifies negative numbers. Notice if we wrote minus 8 times minus 2, well, this is all, it gets jumbled together, our minus sign and our multiplication sign, and it gets a little confusing. So we're going to put our parentheses automatically around negative numbers, but also when we're substituting in positive or negative numbers. Okay, so let's carry out our operations. We have a minus 8 times a minus 2. Negative and a negative gives us a positive. 8 times 2 is 16. Then we have plus 4. 16 plus 4 is 20. So when we let x equal minus 2, this expression has a value of 20. Let's do a few more of these. Let's say we have 6 over y minus 2y plus 1. Okay, don't get excited about the y. We can actually use any variable just as a value holder. And we're going to let y equal a minus 3. So everywhere we see y in our expression, we're going to substitute in a minus 3 to find out the value. And here we actually have y in two different places. But this essentially works the same. We have 6 divided by minus 3. Let's put it in parentheses so we know we're actually substituting into our expression. Then we have a minus 2 times y, which is minus 3, plus 1. So when we look at our expression, we see two variables, and after we substitute, we want to see those variables substituted in by the minus 3 in parentheses. So it's a little more simpler. We can more easily see that we're indeed substituting correctly. Now 6 divided by minus 3 is a minus 2. Minus 2 times minus 3 is a minus 6. Be careful with our signs here. Plus 1. We have a minus, we're subtracting a negative here, so let's go ahead and cancel these and add a positive. It's the same thing And it's a few less minus signs, and I tend to lose negative signs, so I like doing this instead. Minus 2 plus a positive 6, the positive wins out, so you have a positive 4 plus 1, carrying our plus 1 here. 4 plus 1 is 5. Okay, so fairly straightforward. We're just substituting the value of the variable into our expression so we can actually get the value of the expression. All right, let's do a couple more. Let's find the value of 2 over 3 times 3x plus 4y plus z. Okay, here we have 3 different variables, and we're going to have the following values for these variables. We have x equals 5. We're going to let y equal a minus 2, and z equals 7. Okay. We approach this the same way. We have 3 different variables, but we have the values for each of these variables. So all we do is rewrite our expression with our values substituted into our variables. So rewrite the 2/3. We have a 3 times x, which is 5, plus 4 times y, which is a minus 2, plus z, which is a positive 7. Let's go ahead and put that in parentheses, even though it's positive, just so we know, we can see that 3 variables up here, and they're substituted by 3 values down here. And now we can go through our order of operations, which says we're going to take care of what's inside the parentheses first. Parentheses comes first. So we have 2 over 3 times, so now we have 3 times 5, which is 15, plus 4 times a minus 2, which is a minus 8, plus 7. Okay, we're going to rewrite our 2 over 3 because we still have some addition and subtraction essentially inside the parentheses, so we need to work inside out. We can actually combine these 3 terms in one step, kill two steps in one. 15 plus a minus 8 is 7, and 7 plus 7 is 14. All right, now we're going to be multiplying a rational number and a whole number. We can actually convert this whole number to a rational number just to make things a little more clear about what's going on, because we know how to multiply rational numbers. 2 times 14 straight across the top is 28. Straight across the bottom, 3 times 1 is 3. 28 over 3 is our answer. So it doesn't matter how many variables that we have, as long as we have the corresponding values to plug into those variables, we can figure out the value of the expression. Okay? Now let's take a look. Let's say that we have the following values for the variables a, b, and c, and d. A equals 2. Let's say b equals a minus 3, c equals 1, and d equals 4. Okay. Now, we're going to find out the value of the following expressions given the value of these variables. Let's say we have 12a plus 8b. Okay, what do we do here? Well, we know the value of the variables a and b. A equals 2, b equals a minus 3, so we can substitute those values into our expression. So we have a 12 times a, which is 2, plus 8 times b, which is a minus 3. Multiplication comes before addition, so we're going to find out these two products first. 12 times 2 is 24, plus positive and a negative gives us a negative. 8 times 3 is 24. Okay, 24 plus a negative 24 is 0. So this expression is 0 when the value of a is 2 and the value of b is a minus 3. Okay, let's use these variables again, and let's say we have 4c plus 2d. We want to find the value of this expression given these values. So we have 4 times c. C is 1, so let's plug in a 1. Plus 2 times d. D is 4. So let's plug in the 4. Take care of the products first. 4 times 1 is 4. Plus 2 times 4 is 8. 4 plus 8 is 12. So our expression, this expression is 12 given the values for c and d. Okay? Let's take a look at another one. Let's say we have 3a divided by c plus d. Okay, here we have 3 variables, but we know the value of these variables, so let's go ahead and plug them in. We have 3 times a, which is 2, putting our 2 in parentheses because we're substituting in. Then we have c plus d. C is 1, plus d, which is 4. We're still putting these in parentheses, even though we're not multiplying, we're only adding. But we want to be sure that we get in the habit of this, just so we can more easily see that we're substituting in for these variables. Always want to get in the habit of that. So 3 times 2 is 6. 1 plus 4 is 5. And 6 over 5 is our answer. Now notice what we did here in this step. We actually applied 2 different steps at the same time in terms of the order of operations. We multiplied up here in the same step that we added down here. Now we can do this because we can treat the numerator and the denominator separately. We can be in one step up here while we're doing another step down here. And this is perfectly fine if we want to do it in one step. Or we could have just applied the multiplication and rewrote the denominator and did it in 2 steps. But we took care of it in one step. That shouldn't confuse you, but we can actually apply a different step in the numerator as in the denominator. So we always want to remember this so we don't spend a whole lot of time rewriting. It just makes things easier. Let's take a look at another one. Let's say we have 2c divided by d. Okay, so we have 2 variables here, but we know the value of these variables. So let's go ahead and plug them in. We have 2 times c, which is 1, divided by d, which is 4. And still writing our value in parentheses down here, just to get in the habit of it. 2 times 1 is 2, divided by 4. We always want to make sure we leave our rational numbers in lowest terms. 2 over 4 is the same thing as 1/2. We always want to write it in lowest form. Okay, let's do a few more. Let's say we have b minus 2a divided by 4d plus 3c. Okay, here we have all 4 variables, but let's not get excited because we know the values for all 4 of these variables, so let's take one at a time and plug them in. We have b, which is a minus 3, minus 2 times a, which a is 2, and the denominator we have 4 times d, and d is 4, plus 3 times c, c is 1, and now we can go straight into our operations. We have minus 3, minus 2 times 2, which is 4, 4 times 4 is 16, plus 3 times 1 is 3. Now in the numerator we have minus 3 minus a positive 4, so let's go ahead and add a negative here. Minus 3 and a minus 4 gives us a minus 7, and 16 times 3 is 19. Minus 7 over 19 is our answer. Okay, so it doesn't really matter how many variables we have in our expression. If we know the value of these variables, we can figure out the value of the expression. So let's not get too excited about that. Let's do a couple more. We're running out of time, but I want to get a few more in your notes. Let's say we have 1 divided by a minus b. Okay, well we have a constant. 1 is a constant in our numerator, so we can just simply rewrite that. Then we have a minus b. A is 2, b is a minus 3. So we have 2 minus a minus 3. Let's be careful with our signs here. We're subtracting b, and b is a negative, so we have a minus a negative. Rewriting 1 in our numerator, 2 minus a minus 3, we can cancel these minus signs out and add a positive. It's the same thing. 2 plus 3 is 5. And 1/5 is our answer. Let's do one more. Let's say we have A times C over B times D. Again, we have 4 variables, but we know the value of these variables. A is 2, and C is 1, 2 times 1, and then we have B, which is a minus 3, times D, which is 4. Okay, we're writing all 3 in parentheses, just so we can clearly see that we're substituting into our expression. 2 times 1 is 2, minus 3 times a positive 4 gives us a minus 12. We always want to write our rational numbers. We want to leave it in lowest terms. So minus 2 over 12 is the same thing as a minus 1 over 6. We simply factored out a 2 out of the numerator and the denominator. Okay, so what did we learn here? Evaluating algebraic expressions, the expression actually doesn't have a value in itself until we define the variables within it with a particular value. Once we substitute in, using our parentheses for clarity, we can actually find out the value of the expression. So let's make sure, we'll do plenty more of these. We'll actually do another video on these just so we get this down, because this is very important. We'll see it all through algebra. We'll see you soon.